So good day Mapuans, it's Christian Dave here and it's my pleasure to explain what an electromagnetic induction is. So let's go. So is anyone excited to more about electromagnetic induction is? Why don't we call someone Alisa Samantha Chong to explain what an electromagnetic induction is. Alisa?
Thank you so much, Chad. Now let us proceed with what electromagnetic induction truly is. Can you take a walk with me? Electromagnetic induction, in simple terms, is the process of generating an electric current within a conductor by exposing it to a magnetic field. This happens either when a conductor is placed in a moving magnetic field or when a conductor is constantly moving in a stationary magnetic field. Now, let me call on a fellow member of mine to instruct all of you, how do we see electromagnetic field in our daily life?
And I am Khalil Gabriel Galbo, and I will be giving some examples of objects that use electromagnetic induction in our day-to-day lives. Let's take for example this air conditioner. Air conditioners do use electromagnetic induction in their operation. Specifically, they use an electric motor that operates by electromagnetic induction to power the compressor, which in turn compresses the refrigerant gas throughout the air conditioning unit. Other examples include current clamps, induction cookers, Hall effect sensors, and lastly, generators.
So benefits. So what is the benefits of electromagnetic induction? So electromagnetic induction uses magnetic fields in order to produce energy inside of batteries. So electromagnetic induction also makes wireless charging possible, which is a convenient when you want to charge their phone quickly while they're driving, right?
Now that you've figured out what are the benefits of electromagnetic induction, let me tell you about the disadvantages. So, one disadvantage is that electromagnets heat up very quickly. As such, a continuous power supply is required to maintain a magnetic field. Furthermore, electromagnetic induction has limited range since it is limited by the magnetic field it can generate.
And on the other hand, any conductor that is in an electric field will experience a magnetic field when the electric field changes in strength or direction.
So an electric current is produced by induced electric field, which exerts a force on the conductor's electrons. So the magnetic field strength, rate of reversal, and conductor's characteristic all affect how much current is produced.
Hi, now that you're acquainted on what is electromagnetic induction, let us move on to how to solve the electromagnetic induction. But before everything, we must know the formula on how to find it. It will be given by Cholo.
The formula for the law of electromagnetic induction is as follows. Induced voltage is equal to negative number of loop times change in magnetic flux over change of time.
Now that you know what the formula is, let us proceed to answering one of the sample questions. Are you ready? Because I am ready.
For the sample problem, we have a coil of wire with 5 loops is 20 cm on each side. A magnetic field of 0.6 Tesla passes through the coil. The plane of the coil is perpendicular magnetic field. The field increases in 1.8 Tesla in 0.75 seconds. What is the induced voltage in the coil? Remember the formula again? Here we are, and let us use it. So in order to get into the formula that is given, we have to find the final and the initial amount of magnetic field, since we have 2 Teslas given. So in order to find that, we have to multiply the area times the initial magnetic field. So that would be 0.20 meters squared, y meters squared, because in the given we have 20 centimeter and we should only use meter. So why is it squared? Because it is stated here that it appears to be on each side. So 0.20 meters squared times 0.6 Tesla, which is the initial amount, is equal to 0.024 Webers. After that, we will solve for the increase. So we can see here, again, the formula is same for this one. Area times the final magnetic field is equal to, so that is 0.20 meters squared times 1.8 Tesla. The answer is 0.072 Webers. So we will use the both of them to be distributed on the final equation. Here we have everything ready and set, so negative number of loops times the change in magnetic flux over change in time. So since it has been mentioned that the coil of wire has 5 loops, we will substitute that here. That would be negative 5 over 0.048 Webers. Why 0.048 Webers? You just have to subtract 0.072 Webers, which is the final magnetic field, into the initial magnetic field, which is the 0.024 Webers. The answer is 0.048 Webers. So after getting that, you have to divide it with the given time, which is the 0.75 seconds, and you have to remember that the time that we'll be using in this formula will always be in seconds. So you just have to answer that and you will get negative 0.32 volts. That is the electromagnetic induction, or the induced voltage on the coil in this given problem. That is how easy it is.
Everyday living exposes everyone to electromagnetic induction, either more or less. Examples include the magnetic fields produced by kitchen appliances, radio transmitters, mobile phones, computers, and as well as the electromagnetic induction in the AC generator we use, like the ones we have in our home, our bedroom, or even at school, like faculty or the classrooms. I hope everyone has gained some knowledge at the end of this discussion and at the end of this lesson. Thank you so much for listening and have a good day. Goodbye.